Alright, so this is a continuation of the previous video on dimension analysis. This is Mr. Hussein, and we'll be continuing from where we ended in Physics 101. So in this video, I want us to look at the type of problems that you will come across in dimension analysis. And this is the first part, which involves you learning how to find the dimensions of a constant. Alright, so this is quite simple to answer. So now, how can you find the dimensions of a constant? So now there are basic steps that we follow. Step 1, remove the following. The first thing you should remove is simply the numbers. Not just the numbers, as well as the trig ratios. When we talk about trig ratios, we're talking about things such as sine, cosine, tan, sec, and so on and so forth. We also remove things like e or even pi. Then what you should do next is to make the constant the subject of the formula. Then after that, replace dimensions. Alright, so with these simple steps, we'll answer the question that came in your tutorial sheet. So let's answer question 1a. It reads, suppose the displacement of an object is related to time according to the expression x is equal to bt squared. We've been asked to find the dimensions of b. So whatever I ask you to find the dimensions of is simply the constant that is present in the expression. So we have been told that displacement. Now displacement is a distance moved in a particular direction, and it is related to time. So now let us try and solve this. So we don't really have any numbers to remove. We don't have any trig ratios, not even e or pi. So we just make b the subject of the formula, of which we know that this will then in turn be bt squared. You divide both sides by t squared. In the other end, t squared. This cancels with that, and you end up having b is equivalent to x over t squared. Now, after that, all you have to do is to make the constant the subject, of which we have already done. Now the next thing is to replace the dimensions. So now, what are the dimensions of displacement? Displacement is distance. So things like length, distance, displacement, these are the same dimensions because even their units are the same, of which we say meters. So meters, the dimensions of these things is a capital L. Then it is over time. The dimensions for time is a capital T, and this is t squared, so we put a squared to it. And these are the dimensions. Other people would prefer to write this, then dot t to the minus 2. This is one and the same. Now b is similar with a. It says the displacement is related now by x being equivalent to a sine of 2 pi f t, where a is a constant, so we know that the constant here is a. T is the time and f is the frequency. Find the dimensions of a. We've even been given a hint to say a trigonometric function appearing in an equation must be dimensionless, which means should not have dimensions. Now with this in mind, we'll cancel out the things we don't need. We said a number should not be there, a trig ratio should not be there, and even pi should be there, which gives you an expression which is in terms of x being equal to a f t. Now f is frequency, and we know that frequency is the inverse of time, so it's 1 over t. So where there's frequency, we can substitute. But before we even do that, let's make a the subject of the formula. By doing that, we divide both sides by ft, and with this end ft. This cancels with that, and you then have A being equal to x over ft. Now this is division, so others could write it as A being equal to x divided by ft. So I can put ft in brackets and solve it separately. So let's say A is equal to x divided by, what is f? F is 1 over t times t. So you know that 1 over t times t, this can cancel with that, and I'll just end up having A is equal to x divided by 1. Now x divided by 1 is like that, of which 1 into x will literally just give you x. Now x is displacement, and you know the dimensions of displacement are simply a capital L. Upon doing this, then you have solved your work. Alright, so let me give you a task. So simply find the dimensions of the constants A, Q, Z, and P in the expressions below. So question 1, let's say you have say A is equal to MA. So I'll give you hints where M is mass, A is acceleration. Okay, so 2, you will have say this one, one over Z. So here the capital A was the constant. Then we have another one, which F is now the frequency. Z is constant. I'm making things easy for you. Then we can also look at a formula that is relating. What formula can we look at? Let's look at the formula for density. Okay. So let's say this I've given you a hint. And the last one will be, let us take it as Q is equal to this, where this is the force. Alright, thank you for watching this video. My name is Mr. Hussein Mosapi, and please like and subscribe to the channel. For more information, you can actually reach me on the contact that I've actually put on the description. This topic is quite easy, so I'll be a bit fast